Section 5 talks about angle relationships. A lot of the material on this is I'm going to revisit our vocab words, okay, and then just apply some of those definitions. There's a couple of new conjectures that we're going to talk about as well. But remember, angles are formed by two non-collinear rays that share that endpoint. That's called the vertex, okay? And back in, gosh, middle school or elementary school, I'm sure you've talked about acute, obtuse, and right angles. Remember, acute angles are greater than 0, less than 90. Obtuse angles are greater than 90 but less than 180 degrees, and right angles are exactly 90 degrees. All right? Two adjacent angles are angles that share a vertex and one side, okay, but no interior points, okay? So all of the interior points for angle 1 are going to be completely separate from the interior points of angle 2, okay? But they have to have a common vertex and they have to share one side, okay? Linear pair, think of linear like line. We've got a pair of adjacent angles, okay, so they still share an endpoint and a side, but those non-common sides are opposite rays. Okay, so common endpoint, the vertex, and that shared side, but these non-common sides are opposite rays. And so you will always find a straight line when we're talking about linear pairs. Okay, so angle 1 and angle 2 here, that's a linear pair of angles. Okay, vertical angles are non-adjacent, but they are formed by intersecting lines. Okay, so vertical angles will share a vertex, but that is it. They do not share any sides. Okay, so angle 1 and angle 2 are vertical angles. And then angle 3 and angle 4 are also vertical angles, okay? Now, our vertical angle conjecture says that all vertical angles are congruent. Okay, so not only are 1 and 2 vertical angles, but angle 1 is congruent to angle 2. Their measures are equal. And angle 3 is congruent to angle 4. Okay. So let's take a look at some examples. Okay. For these first 3, your answers will vary. They don't have to be the exact same as mine. I'm not going to list every single answer possible. Okay. But if you have a question about it, about a particular answer, feel free to ask in class. Okay. Using this figure here that looks like some intersecting roads, we want to name a pair of angles that form a linear pair. Okay, so remember, linear pair, we want to find a straight line. So, I'm going to, if I look at this line, okay, I can break that up into these two angles. Angle UIQ and angle QIR. Okay, so again, linear pair, find a straight line, and then split that into two separate angles. Okay, now two acute adjacent angles. Acute meaning less than 90 degrees. So I'm going to use angle QIR again. That's an acute angle. Okay, and adjacent means they share a vertex and one of the sides. So I'm going to say angle QR. Nope, I'm sorry, angle RIS. Okay. Now a pair of obtuse vertical angles. So obtuse is going to be bigger than 90, but not bigger than 180 degrees. Okay, so I'm going to look at the angle UIQ again. Okay, UIQ, that's one of my angles. Okay, now vertical angles, if I continue this, remember, they're intersecting lines. Okay, so I've got to continue this line this way, and this one this way. Okay, here is my other angle that is going to be paired with it. Okay, so that's angle RIT. All right, like I said, your answers might not be the exact same as mine. Okay, that's fine. If you have a question, please ask in class. Okay, 4 and 5 are multiple choice. Okay, this might be like something that you see on a test or even on a standardized test. Number 4 says name 2 adjacent angles whose sum is less than 90. Okay, so let's go through these options, and first let's pick out adjacent angles. Okay, angle CAD looks like 55 degrees and DAE is 95 degrees. So those are adjacent. Okay, but their sum, 55 plus 95, is not less than 90 degrees, so that can't be an option. Okay, B, FAE and FAN. Okay, those are adjacent angles. They share the ray FA and that vertex A. All right, their sum is 85 degrees, so that's our answer. Okay. Now, number 5, it says name 2 acute vertical angles. Okay, so let's look at, we'll go through our choices here. All right, we need acute angles and angles that are not adjacent but vertical. Okay, so angle BAN, and I immediately see that, hey, that's 95 degrees. That's not an acute angle, so it can't be option A. Okay. Now, angle BAD, well, BAD is all of this, so 30 plus 55 is 85, so that's acute, okay? And BAN, but angle BAD and BAN are not vertical angles. That's actually a linear pair, so it can't be B. All right, angle BAC is 30 degrees, so that's definitely acute. Now let's look at CAE. Oh, that is definitely not acute, nor is it a vertical angle. So it can't be C, but let's just double check. Angle FAN is 55 degrees. DAC is also 55 degrees. Okay, and we've got this line and this line intersecting. So there's our vertical angles. Okay, now back to some vocab. Complementary and supplementary. Complementary, their sum is 90 degrees. Supplementary, their sum is 80 degrees. Okay, so here, angle 1 and angle 2, they're adjacent, and their sum is 90 degrees. We've got this symbol here, okay? But complementary angles don't have to be adjacent. They can be two completely different angles as long as their sum is 90 degrees. So measure of angle A plus the measure of angle B has to be 90 degrees. Okay? They don't have to be next to each other, but their sum has to be 90. Same with supplementary angles, okay? 3 and 4 here, they are adjacent to each other, okay? And their sum is 180 degrees, but they don't have to be. Just like angle P here, that's 120 degrees. Angle Q is 60 degrees. When we add them together, we get 180 degrees, okay? Now, linear pair conjecture says that the angles in a linear pair are supplementary. Always. Okay, So even though we don't have measures for angle 3 and angle 4, we know that their sum is 180 degrees. Okay, because they are a linear pair, and that will always be the case. Linear pairs are always supplementary, but supplementary angles don't always have to be linear pairs. Okay. Now we're going to go into some word problems. Okay. And I want you to treat these word problems like a system of equations. Okay. It says find the measures of two supplementary angles. Okay, so we've got two angles that are supplementary. That tells me I've got two things that when I add them together, my sum is 180 degrees. Okay, that's one of my equations, and I haven't even gotten a third of the way through this problem yet. All right, the measures of one angle, okay, so it doesn't matter, we can make it x or y. One angle is 6 less than, so 6 less than, I'm going to take 6 away from something, 5 times the measure of the other. So 5 times the measure of the other is 5x. Okay, and we're going to solve this just like we would a system of sub-equations. Okay, I see substitution. I can take all of this and put it in up here. So x plus 5x minus 6 is 180. I can simplify that left side. Add 6 to both sides. Okay. And then when we divide by 6, our x value ends up being 31. Okay, so one of our angles is 31 degrees. And to find the measure of our second angle, we're going to go ahead and substitute that x value in. So 5 times 31 minus 6 gives us a measure of 149 degrees. Okay. Number 2, find the measure of two complementary angles. Okay, so complementary means that the sum is not 180 but 90 degrees, and one angle measures 6 degrees less than 5 times the measure of the second, so that's the same equation from the first problem. Okay, again, I see substitution. You don't have to do substitution. Okay, so x plus 5x minus 6 equals not 180 this time, but 90. 6x minus 6 is 90. If we add 6 to both sides, we get 6x equals 96, which means that x is 16. Okay, so one of our angles measures 16 degrees. And then I'm going to go ahead and substitute that x value in to get our second angle. That's a measure of 74 degrees. Okay, a good way to check both of these, remember, supplementary means their sum is 180, so as long as 31 plus 149 is 180, we're good. Complementary means they add up to 90, so 16 plus 74 is 90. Okay. One more word problem. Says find the measures of two supplementary angles if one angle measure is 18 degrees more than 8 times the measure of the other. Okay, so important words again. I've got supplementary angles. One angle's measure is 18 more than 8 times. Okay. Now I can substitute this expression in for y. Simplify the left side. Subtract 18. Divide both sides by 9, and I get x to equal 18. So one of my angle measures is 18 degrees. Okay. Then for the second one, let's say 8 times 18 plus 18. That gives me my second angle measure of 162 degrees. Okay. Now, two line segments or lines or rays that form a right angle or a 90-degree angle, those are called perpendicular. Okay. We use this upside down T to say that two things are perpendicular. So in this picture here, we've got line AD, or line segment AD, whichever you want, is perpendicular to line BC. All right. Now, a couple things happen when we have perpendicular lines like this, okay? We have not only one right angle, but 4 right angles. Okay, this is a right angle, but this is a right angle. That's a right angle, and that's a right angle as well. Okay. And vertical angles are always congruent, but now we have adjacent angles that are congruent as well. Okay. So some examples. All right, we want to find x and y so that line KO is perpendicular to HM. Okay, so if these are perpendicular, all of these guys are going to be right angles. Okay, you can't see what I'm drawing. All right, so I look here, 3y plus 6 has to equal 90 degrees because that has to be a right angle. Okay, subtract 6, divide by 3, and we get y to be 28. Okay. Now these two angles are adjacent to each other, so just like when we've got two small line segments added together to make a whole line segment, we can treat these two angles the same. Okay. That angle 3x plus 6, angle KJI, plus angle IJH, or that 9x. Those two angles have to be 90 degrees when they add them together. These are complementary angles. Okay. So simplify the left side, we get 12x plus 6 equals 90. Subtract 6 from both sides. We get 12x equals 84. And when we divide both sides by 12, x equals 7. Okay. And number 2, small typo, we want to find x so that AD is perpendicular to CE. So very similar to what we just saw. We've got two angles that are a part of this right angle. So we have to know that, not 54, 5x plus 4x is 90 degrees in order for these two lines to be perpendicular. Okay? So if 9x is 90, x is going to be 10. Okay? This last bit of section 5 are about things that you can and cannot assume. Okay? Some of the big ones, you can assume that lines are collinear. Okay? Assume that any line that looks like a straight line is. If you see straight lines, you can assume things are linear pairs. You can assume things are supplementary. Um, those are some of the big ones to take away. All right, things that you cannot assume. You cannot assume that segments are congruent. You cannot assume that angles are congruent, and you cannot assume that lines are perpendicular um, or even parallel for that matter, but we haven't gotten to that point yet, okay? So unless they are marked on the diagram, do not assume it. Okay, so down here, these examples, I'm looking at angle TYW and TYU, okay? Since I can assume that this is a straight line, all three of these points are collinear, ray YT intersects here. I can assume that those are supplementary because those two angles make a linear pair. Okay? So yes, we can. We can assume adjacent angles as long as they are actually adjacent. Okay? So if I look at VYW and TYS, oh, well shoot, those aren't even adjacent. Okay, remember, they do share that vertex, but they have to share a side too. Okay? So, explaining, just by definition, they aren't adjacent. Okay, if they were, we could assume. But since they're not even adjacent angles, we can't assume that they're adjacent. Okay? And then angle VYT, remember, the only time we can assume right angles is if they're marked in the diagram. So angle VYT, okay, this angle here that is adjacent to it is marked as 90 degrees. So remember, one of the things that happens when we have perpendicular lines like this, not just one angle is a right angle, but all four angles are right angles. So we can. Okay.